Good afternoon to all those who are present. So I think people are still joining. So first, I would like to take questions. Those who are live, those who are online right now. If they wish, they can ask questions. Okay, if not, then I'll take the question from the Google Sheet. So there's one question which says how to design gate driver in detail, like estimating the gate resistor for a given frequency of a certain MOSFET and gate driver IC, and calculating the rise and fall time and ensuring that the total gate charge is fully charged and discharged in the high frequency. So it's a long question. So first of all, about estimating the gate resistor for a given frequency for a certain MOSFET. This problem, this was already given in the assignment. I hope you have solved the assignment, which gives the first clue of how to calculate the gate resistor. Apart from that, there is like you can see the data sheet first that gives you a first estimate of what the gate resistor could be. Because if you observe the data sheet very thoroughly, you will see that whatever specs the datasheet manufacturers, the manufacturers of the devices who have made the datasheet, they first tested the device while using different gate resistor values. And the most suitable value, which will be giving lesser losses, is what they use. So that's like the first idea of what your gate resistor value could be. Plus those assignment problems were also given, that also you can see that will also give you. And further fine tuning them is something that you do at the experimental stage. When you do the experiments, you see that with a particular gate resistor value, what switching characteristics you are getting. If you are getting your rise times and fall times while testing the device as per your requirements, then you can just go with that. And if you see that now this doesn't work, then you have to adjust it. Now the question is whether you increase or decrease, in which direction do you go? That's what you have to decide. So now if you increase the gate resistor, then the transients are going to be longer. That means the switchings are going to take longer time. Your rise time and fall times are going to increase. And if you reduce it, then your rise time and fall times are also going to reduce. So I'm sorry, I said the opposite. If you keep the gate resistor high, then your rise time and fall times are going to increase. And if you keep the gate resistor small, then your rise time and fall times are going to reduce. So this is what is the trend that we observe. And now the one that gives a trade-off is what is the how much dissipation that you can responsible for your losses that are going to take place. If your rise times and fall times are more, then your switching losses are going to increase. But then how much can you increase? That is dependent on what is the thermal power design that you wish to do. So with gate resistor, to some extent, you can play with that, your switching characteristics, what you can achieve, while after you have designed the converter. And if you keep them too sharp, then you may also be ending up problems with electromagnetic interferences. So that is another problem. So it's like a middle thing that one has to choose. And then you're calculating the rise times and fall times. So calculating rise time and fall time is not really required. That is already given in the data sheet of the devices, what will be the rise times and the fall times. And something more than that is what you can expect when you're doing, after you've designed the converter and you're doing the experiments. It may not be exactly the same what is written on the data sheet. And then the total gate charge is fully charged and discharged in the high frequency. So this you don't have to really worry while you're doing the experiments. That automatically will be happening. So I would strongly recommend you please go through those lectures where I am describing these again, and you will have more clarity on it. That was the Google Doc question. Any further questions from those who are present? Okay, I think someone has raised the hand. Akash Singh. Yeah, Akash, you may ask your question. Akash, you need to unmute yourself, and it will be better if you can turn on your video also. You can ask your question.
Hello, ma'am. Sorry, it mistakenly happened.
Yes, Akash, please go ahead with your question. Although I don't see your video though.
Hello, ma'am. Sorry, it's mistakenly happened. I'm just raised there.
Okay, okay. Okay, so those who are present, they can introduce themselves. Akash Singh and Chandana. Okay, I see another question on Google Doc that is it's something related to account login. So I would suggest if you have problems related to account login, please contact the CT team or the NPTEL team, or you can also inform the TAs about it. They'll be able to help you with the problem. Hello, Rekha. Are you there? What am I supposed to do? Because I have answered the question that was there on the Google Sheet, and the people who are live are not asking anything. Okay, okay. Okay. Okay, there is a question which says in examination, what will be the question asked, more multiple or more of most of calculation based question? So it will be combination of both. You will have multiple choice questions also as well as your problem solving based question. And for doing well in the exam, please do the assignments properly. Ensure that you have understood the assignments thoroughly. Then you will be able to do the exams very well. Okay, Rekha, it's 4:40 now. So no more questions I see on YouTube also. Okay, so then I think we'll end it. Yeah, okay. Thank you so much. Thank you. Thank you everybody for joining. Thank you.